All right, we are looking at kind of a different topic today. It's similar figures, areas, and volume, section 9-8. It is a little different. If you take good notes, it's really not that difficult, but there are some different steps to it, so make sure you take good notes. All right, so here's our first definition, areas of similar figures. If the ratio of the corresponding lengths of two similar figures is A to B, then the ratio of their areas is A squared to B squared. Okay, write that down and then I'll explain it on the next slide. All right, so it says the ratio of the lengths of the corresponding sides of two similar triangles is 18 to 11. So this is corresponding with this, so my ratio is 18 to 11. If you remember on the previous slide, it said if it's A to B, then the ratio of their areas is A squared to B squared. So all I have to do is take 18 squared to 11, oh, it's a colon, sorry, to 11 squared. So 18 squared is 324. Ugh. 324 to 121. That's your answer. Okay, here's another one. So if trapezoid DEFG is similar to trapezoid HIJK, excuse me. Okay, so it's saying that they're similar. That means that we can go ahead and we can use this rule, okay? So the area of the trapezoid is 190 centimeters squared. What's the area of trapezoid HIJK? Well, if they're similar, then I can take these two lengths, our 12 squared to 17 squared. All right, I'm going to make that 144 to 289. Okay, that's my first part. Now I have the ratio of my areas. Now I'm just going to write a proportion. So I'm going to say 144 is to 289 as, well, they gave us DEFG is 190. That's this one. That goes with your 12. So that's on the top. So my 190 is here. Ugh, sorry. And then we're going to figure out what the other one is by cross multiplying. Okay? So then all I do is grab my calculator and I'm going to take 289 times 190, divide that by 144, and I get about, oops, grab my pen. Okay, so X is about 381.32, and that would be centimeters squared. And then just to make sure our answer is logical, this one's bigger than this one, so this area should be bigger than this one. Okay, so it seems accurate. All right, here's another one. The area of triangle XYZ is similar to triangle LMN. So the area of triangle XYZ is 80. What's the area of triangle LMN? Okay, so again, we're going to take our lengths, which in this case is 12 to 9. Now I could reduce that. Okay, so I could make it 140. You're going to square it, right? So it's going to be 12 squared to 9 squared, which is 144 to 81. Which I can reduce, or I could have reduced it from the beginning. 12 to 9 would be the same thing as 4 to 3, and this would also then reduce down to 16 to 9. When you're cross multiplying, it's not going to matter. You're still going to get the same answer. But on a test, if I asked for the reduced answer, this is the one I'm looking for the ratio of the sides. Okay? Looks like we need to name our shape here. LMN. LMN, so then X, Y, Z. Okay, so let's write our proportion. So we have 16 is to 9. All right, 16 is to 9. So my bigger one is to my smaller one. XYZ is 80. XYZ is here. That's our smaller one. So that's going to go here, and then I just cross multiply. Okay? So I got 16 times 80 and divide by 9. So about 142.2. Inches squared. Okay? Okay, now we're gonna have volumes. So volumes is similar to space figures. So those were, just like triangles. These are gonna be your three-dimensional shapes. So if the ratio of the corresponding lengths of two similar space figures is A to B, then the ratio of their volumes is A cubed to B cubed. So similar to the other, except we're gonna cube it instead of squaring it, okay? So two cylinders are similar if their diameters are in the same ratio as their heights. What is the ratio of the volumes of these two similar cylinders? Excuse me. So let's see, 3 is to 4 and 6 is to 8. That makes sense, right? This doubled and this doubled. That means that these two are similar. So therefore we can get the ratio of the volumes of the two cylinders. And we can use either one. Let's take the reduced one, okay? So it'd be 3 cubed to 4 cubed. 3 times 3 is 9, times 3 is 27. 4 times 4 is 16, times 4 is 64. I do the same thing on that one. Okay, I could do 8 cubed is to 6 cubed. I still get the same answer. It reduces down to 27 to 64. Two similar rectangles present. Okay, so this one is 7 to 4. And the volume of the larger one is 210. What's the volume of the smaller one? Okay, so I take my 7 is to 4, and I'm going to cube them. So 7 times 7 times 7 is 343. And 4 times 4 times 4 is 64. Then I'm going to write my proportion. 343 is to 64. The 210 is the larger one, so that's my top number. And then I'm going to cross multiply for the volume of the smaller one. So I'll go 64 times 210, and then divide that by 343. So it looks like it's about 39.18. And that one would be meters cubed. Okay, so same thing. We got 6 inches and 10 inches for a diameter. And again, we can do the same thing. So you've got 6 is to 10. And again, I can reduce that to 3 is to 5. Then cube them. So 27 to 125. So 27 is to 125, as 56 is the smaller one. My smaller number is on top. Cross multiply. 125 times 56 divided by 27. About 259.26. And that would be inches cubed. Okay. How do you decide if two space figures are similar? If their bases are similar and all other sides are proportional. So here, my bases, 30 is to 18 as 30 is to 18. So those are fine. They're both squares, so they're going to be similar figures. So if they asked us, if the surface area of this one was such and such, what would be the surface area of this? We could do that because these two shapes are similar. Okay. This one, all right, looks pretty good, except red flag right here. They can't both have a height of 40 and then have different lengths here. So this one would be a no. These two are not similar. Okay, and that's it.